So the point of this long, rambling anecdote is to tell you that the rising carbon dioxide in the atmosphere is one of the touchstones of the modern environmental understanding of how our whole Earth system works. And it has generated an enormous amount of effort to try to understand the climate system. It's said that the effects that the rise in CO2 and other greenhouse gases that accompany it is having an effect on the climate system, and we are the first generation to see that man is really affecting the climate system. And we're going to be the last generation to escape its major effects. Something like 65% of the increase in CO2 each year now is caused by the increased use of fossil fuels in Southeast Asia, especially China, but everyone else in Southeast Asia, who has learned how to use motors to pump water, to ride on bicycles and make cars and so on and so forth. So the increase in the concentration in CO2 is mostly caused by man's activities. But there is another reason I'll get to in just a moment, and it's the important one for today. Now, the other reason why the CO2 in the atmosphere is going up so quickly is because not only are we putting more up there, but those processes that absorb carbon dioxide on the Earth are beginning to degrade. First of all, the ocean's capacity to take up carbon dioxide has been going down dramatically. Now, these little numbers along here are fractions. They go between 0 and 1, and they're the fraction of the CO2 emitted by humans and put up into the atmosphere that's absorbed by the ocean, by the land, and by the atmosphere. Now, you'll see that the one at the top is going up slightly. That's the atmosphere. And that's approaching 50%. Soon it will be over 50%, meaning that half or more of what we're putting up there is staying in the atmosphere. The other one here is the land. This is the one that's the subject for today. The land so far seems to be holding its own. Now, as a fraction of what's going up in the atmosphere, if it's holding its own, it means it's taking up more CO2 all the time. This one clearly means the atmosphere is taking up more CO2 all the time. The ocean, in fact, its capacity to take up CO2 is really declining, as is, and so the rate as a fraction of what we're putting up there is declining quite rapidly. Now, the effects of this are generally warming. We talk about the effects of carbon dioxide in the atmosphere as warming the atmosphere. That what we thought about climate change as little as 5 years ago has had to be revised quite dramatically recently, because things are happening much faster than we thought. The big ecosystem that you're worried about losing here is the Great Barrier Reef. In fact, in opinion polls, that appears to be, in most people's mind, the most serious consequence of climate change for Australians, and you're prepared to do something to save the Great Barrier Reef. But I would submit that you've got a lot more than that to worry about, because the Murray-Darling system is the center of your breadbasket, and it appears that the amount of rainfall that is going to fall on that system is going to be declining with time. That's a point I'm going to make in a moment. But the polar bear is worrisome, but even more worrisome is the lack of ice at the top of the pole, at the top of the planet. Because while that ice melting doesn't change sea level, it changes the absorber for solar radiation. When the ice goes away, there's a larger and larger absorber to heat up. When the ice is there, the reflected sunlight keeps the Arctic relatively cool. As the ice goes away, more and more sunlight is absorbed, the water warms up more, and you have a kind of a cascade of effects. The climate change effects that we have heard a great deal about are more frequent heat waves. Heat waves are the things that kill people. A few years ago, there was a big heat wave in Europe, and in the month of August, 35,000 people died in France, Italy, and in Portugal. Some say this was a failure of the public health system, but it really was because it got too hot and the people couldn't take it. And frequent heat waves are going to be the norm instead of unusual in the future. More intense hurricanes, and we certainly know about that in the United States. Hurricane Ike has just swept through Texas, and you've seen all the news about that. It was devastating. Many people lost their homes. In terms of property loss, hurricanes, out here you call them cyclones, these are the really big things. Melting glaciers and sea ice. Around the world, the glaciers in the mountains are melting. 90,000 of the world's largest glaciers are melting. A few are not, but most of them are. In Southeast Asia, people depend in dry years on meltwater from glaciers. About a fifth of the world's population depends on meltwater from very large glaciers. And that is going to be disappearing because those glaciers will be gone this century, and they will no longer be a source of water for people who need it during the summertime. We talked about the sea ice a few moments ago, but the really big glacier that's melting is Greenland. Greenland is now melting faster than ever before, and every time people look at it, it appears to be accelerating. If Greenland melts completely, and we don't know when that's going to happen because we have so little experience with this, but when it melts completely, there's enough ice on Greenland to raise sea level by about 5 meters. Now here in Sydney, that may have some effect. The River Cat, of course, may go all the way from Parramatta maybe to Richmond. I don't know how far it can go, but 5 meters would make a great difference in the way that River Cat comes up to Parramatta. In the United States, we have a very flat country, and we have a lot of property very near sea level, and that would be disappearing. New York City would be in for big trouble, and New York City is likely to be in for big trouble long before we get to a 5-meter sea level rise because big storms bring piles of water in front of them. A hurricane like the one that hit Texas, if it hit New York City now, would bring a 20-foot wave of water and completely finish off what's left of Wall Street. Wall Street is very near sea level and sinking fast. Rising sea level, I've just mentioned that. The big one, however, for you folks here in Australia is extremes of rainfall and drought. What the models all say is it's going to get wet in the wetter places and dry in the drier places, and that means Australia. Australia is a really dry climate, and it's thought that the climate change effects are going to be bigger in Australia than for any other continent, and largely because it's a dry continent. Now let's look at the globe. That model I just gave you is a very simplified thing. It doesn't happen that way everywhere. For example, up here in the Arctic, there is a lot of carbon in the soil, and it's cold, and the sensitivity of photosynthesis to temperature is acute. If you raise the CO2 a little bit, nothing much happens to plants in the Arctic because it's just too cold. But if you raise the temperature a little bit in the Arctic, you begin to dry it out, and you begin to drive carbon up into the atmosphere. And the Arctic is full of places that look like this. This is a pulsar up here at 70 degrees north latitude, 30 degrees east, right on the border with Russia. And we're concerned that if this warms up, methane and carbon will begin to come out of that really rapidly. And that is bad dream number one in something we call the nightmare scenario.